In this video, we'll work through the Fourier transform of the function f of x equals h times 1 minus a times the absolute value of x for absolute x less than 1 over a and 0 otherwise. We'll solve this step by step. First, let's break the function into regions based on x. We can define this in 4 different regions. First, from minus infinity to minus 1 over a, then from minus 1 over a to 0, then 0 to positive 1 over a, and finally from 1 over a to infinity. For all these regions, we have to define the value for f of x. From the given limits, we can clearly say that the function is 0 from above 1 over a and below minus 1 over a. Then we have to define the value between minus 1 over a to 0. So here x is negative. From minus 1 over a to 0, x is negative. So the function will be h times 1 plus a times x. And then from 0 to 1 by a, that is 1 over a, x is positive. So f of x will be h times 1 minus a into x. Next, let's draw the function. Between negative 1 over a to 0, the function represents a line equation mx plus c with positive slope ha. And from 0 to 1 over a, it represents a line equation with negative slope minus ha. Now, notice that this function is even, meaning it's symmetric about the y-axis. So, we only need to compute the Fourier Cosine Transform, which simplifies things significantly. The formula for the Fourier Cosine Transform is g of omega equals the square root of 2 over pi multiplied by the integral from 0 to infinity of f of x times cosine of omega x dx. But since f of x equals 0 for absolute x greater than 1 over a, we can limit the integral to 0 to 1 over a. So it becomes the square root of 2 over pi multiplied by the integral from 0 to 1 over a of h times 1 minus a times x cosine of omega x dx. Now expanding and separating the integral will get, so we can take h outside because h is constant. So the integral can be written as integral from 0 to 1 over a cos omega x dx minus, now we have to multiply the ax right now. So we'll get minus integral 0 to 1 over a times x cosine of omega x dx. So let's consider this as equation number 1. Now we have to solve these integrals one at a time. The first integral is straightforward. So the integral of cosine of omega times x from 0 to 1 over a is equal to sine of omega times x over omega evaluated from 0 to 1 over a. Now if we substitute the limit, we will get sine of omega over a divided by omega minus sine 0 by omega. So the first term becomes sine of omega over a divided by omega. Now let's solve the second integral. A times the integral of x times cosine of omega times x from 0 to 1 over a will use integration by parts. Let u equals x and dv equals cosine of omega times x dx. Then du equals dx and v equals sine of omega times x over omega. So applying the integration by parts formula, we will get uv minus the integral of v du. So the first term uv becomes ax times sine of omega times x divided by omega evaluated from 0 to 1 over a minus integral from 0 to 1 over a sine omega x dx by omega. Now we have to do the integration. So in the first term, we have to substitute the limit. So x becomes 1 over a and sine of omega over a divided by omega. And when we substitute the lower limit, it will become 0. So we're not going to do that. So and then coming to the second term, we'll get negative of, when we integrate sine omega x, we will get minus cos omega x by omega. Since we already have omega, the lower term will become omega square and the limit will be from 0 to 1 over a. This will become, so let's multiply a inside. So a will get cancelled out. So the remaining we will get sine of omega over a divided by omega. And in the second term, minus into minus will become plus. So a into cos omega over a divided by omega square, and then we're going to substitute the lower limit, so minus a cos 0 divided by omega square. So this will give us, the first term will be as it is, sine omega over a by omega, then plus a by omega square. So in the second and third term, we are taking a by omega square outside. So a by omega square into, the remaining terms will be cos omega over a minus 1, because we know cos 0 is 1. Now we have to substitute these values in equation 1. So equation 1 is g of omega is equal to square root of 2 over pi multiplied by h into integral 0 to 1 over a cos omega x dx minus a times integral 0 to 1 over a x cos omega x dx. So here if we substitute it, we will get square root of 2 over pi multiplied by h. For the first integral, we have to substitute sine omega by a by omega. And for the second one, we have to substitute minus of sine omega over a by omega minus a by omega square cos omega over a minus 1. Here the first term and the second term will get cancelled out. So the remaining terms will be square root of 2 over pi h times a by omega square minus cos omega over a, minus into minus will become plus 1. So this is the remaining term. So now we can rearrange it. So when we do it, we will get g of omega is equal to square root of 2 over pi h times a over omega square into 1 minus cos omega by a. This is the Fourier transform of the given triangular function.